You may have already read a lot about how climate change and global warming are affecting extreme events. We haven't officially defined extreme events, but I think you have an intuitive sense. A hurricane is an extreme event, of course, but even rain and heat waves, for example, if you are in a region where normal rain is, let's say, about 10 millimeters per day, but if it pours 150 millimeters or 200 millimeters in one day, you know that's going to create massive problems, and you would call that an extreme event. And there are technical definitions of 95th percentile of rain, 99th percentile of rain, and the same thing can be done for temperatures as well. If the warmest temperature you expect is 50 degrees centigrade, for example, which is pretty damn hot, and if you keep hitting that, and that happens only once in 100 years, but you keep hitting it again and again, then you can expect that the frequency of extreme events is increasing. So what climate change does is so-called loading of the dice. So heavy rainfall and heavy heat waves may happen naturally, but let's say they only happen once in 100 years. What climate change will do is shift that frequency or the return period to make it more frequent. So once in a 100-year event may begin to happen once in 50 years or 20 years or 10 years, and once in a 10-year event may begin to happen every other year, and so on and so forth. Okay, so it's not just the frequency, it's not just the intensity of the extreme events, but also the frequency of extreme events. So just touching again on the cumulative anthropogenic CO2 emissions from 1870 for what we have been doing already till about 2010, and what is projected for various scenarios from 2.6 to 8.5, and the warming that we can expect. And here is the cumulative total anthropogenic CO2 emission from 1870. Okay, this is in gigaton CO2 and this is in gigaton carbon, so you can see the conversion factor there of 3.7 or so. Okay, so the detection and attribution we already talked about. In changes of classes of extreme storms, for example, gives you a sense of what the understanding is and what the data is. So here is the physical understanding on a scale going from low to medium to high. This is from NOAA. And data to define these extreme events going from low to medium to high. So in terms of thunderstorms and winds and ice storms for the US, the understanding is low and data is not sufficient. But if you move into tornadoes and hailstorms, physical understanding is medium and data is still not sufficient. But if you move to hurricanes and snowstorms, then the understanding is at medium level, defined as some scale that I don't want to get into the details. Data is better than these, but as for precipitation, physical understanding of what causes extreme rainfall is high, and the data we have to look for precipitation extremes and to classify them and even to predict them and so on is high. This basically goes back to the idea of Clausius-Clapeyron equations, how much humidity increases with each degree of warming and how that leads to extreme rainfall based on where you are and how you define it, 95th percentile, for example, or just millimeters per day and so on and so forth. Okay, so this is a nice plot. I think Van Oldenburg did that. Unfortunately, I think he passed away recently at a very, very young age, in his 50s. So trend in highest daily mean temperature of the year. The way it is done here is, it is going from minus 2.5 to 2.5 times the global mean temperature rise. So instead of looking at how much it is warming locally, Here it is being looked at as a global warming of, let's say now we are at 1.2 degree centigrade or so since the Industrial Revolution. So you expect that some places there is amplified warming. So we already talked about polar amplification, for example. And there are, which means some places there has to be less warming because the average gives you some value. So there are many places across the globe where the trend in the highest daily mean temperature of the year is 2.5 times, look at the dark color here, 2.5 times the global warming rate, global temperature rise. And there are places which are less, and there are places where it is actually much smaller. It's cooling compared to the temperature rise at the global mean, which has to happen because global warming is the mean over some positives and some negatives, as we talked about. But there are hotspots. The hotspot down here in Australia, hotspot in parts of Europe, hotspots in the western US, and some parts here, and so on. Okay, so all the way into these polar amplification regions as well. Trend in the lowest daily mean temperature of the year. Oh, excuse me. My throat got dry. So going -5 times to 5 times the global mean temperature rise. So the lowest daily temperatures are rising faster than the highest daily mean temperatures for various dynamic reasons. You can see here again many hot spots where the lowest daily mean temperatures are increasing, which again is bad news in terms of insects, pests, wildfires, crop damage, and so on and so forth. Okay, this is the trend in logarithm, highest daily precipitation. So this is going from -28% to 28% per degree global temperature rise. So per degree temperature rise, water vapor increases 7% by Clausius-Clapeyron equation. But how does it translate to precipitation change? You can see that that can be much larger, -28% to 28%. We talked about regions which are getting drier and wetter, regions that are giving moisture to the wetter places, so rich get richer and poor get poorer kind of syndrome happens when it comes to evaporation and precipitation. So you can see that India is a hotspot for extreme events, so that means there are droughts, extreme droughts and extreme floods being created over India. We will see when we look at regional trends that Indian floods, extreme events are also getting larger in spatial scales. So here you can see that precipitation is decreasing. So the reds here are negatives. So you have persistent long-term droughts happening in western US, which have caused a lot of problems for agriculture, drinking water, and so on and so forth. There are places where heavy rains have increased. So China is also a good mix of sorry, I'm in the US. Eastern US is also a good mix of droughts and floods, and you can see here extreme heavy rain, 28% per degree temperature rise. Same over Australia. This is the warm, wet part. This is the drier part down to the south, and so on and so forth. Okay, so you can see the scales of precipitation change and scales of temperature change are very different. As we said before, the correlation scales of temperature are always larger than precipitation. Cyclones are a tricky thing. The total number of cyclones have to be always considered, and there are several regions where cyclones are born. They're called hurricanes here, typhoons over in the Pacific region, and cyclones over here in the Indian Ocean region. 30% of annual cyclones or typhoons or hurricanes, total number of cyclones, 30% of the total number happen here in the hotspot. And you can see the number per year. It is decreasing here. This is the observed trend in tropical cyclone frequency of occurrence over 1980 to 2018. So they have increased per year over here by 0.14 or so. They have decreased over here. Southern Ocean, there is large southern hemisphere, there are large decreases. North Indian Ocean, they have increased, especially during the post-monsoon season. So cyclone seasons are not the same everywhere. Here it starts on June 1st and goes till November 30th, but now it's expanding during the calendar year. There are 2 seasons here, 2 seasons here. Relates to how the conditions are favorable for cyclones to grow and so on and so forth. But the cyclone story is also that they are probably intensifying more rapidly now because the ocean is warmer, there is more energy available, and maybe cyclones are moving slower as well, which means they are dumping more rain when they park near the coastlines and so on and so forth. Just to look at a little bit more detail of the Indian Ocean, for example, Indian Ocean during 1891 to 2017 would get about 5 cyclones per year. 4 would develop over the Bay of Bengal and only 1 over the Arabian Sea. But if you look at more recent periods of 2017 to 2019, we had 3 cyclones in 2017, 7 in 2018, 8 in 2019. Of those, severe intensity went from 2 to 6 in 2018 and 19. Is that a trend? Of course, you have to be careful, but the question is, when you have so many poor countries and developing countries on the rim of these oceans where cyclones hit, then you have to be very careful about how long you want to wait before deciding whether it's a trend or not. You have to get ready nonetheless. Bay of Bengal versus the Arabian Sea. There are strong contrasts between the 2 oceans for various climatological reasons. This is a very warm ocean. This is not so warm. During the pre-monsoon it is warm, but during the monsoon it gets colder. So Bay of Bengal is warmer than the Arabian Sea, thus providing necessary cushion for a cyclone to form. This is specific cyclones here, but 2017 there was 1 in the Arabian Sea, 3 in 2018, 5 in 2019, whereas Bay of Bengal had 2 in 2017, 4 in 2018, and 3 in 2019. 2021 post-monsoon has been the quietest since 1990 in terms of the cyclones, post-monsoon cyclones. So obviously there is a variability, and as I said before, global warming doesn't always increase things continuously, but it loads the dice. So the number of years with record number of cyclones will continue to grow. Doesn't mean every year we'll have more cyclones than the previous year. So you may have a bumper year and then quiet years, and then again a bumper year for cyclones, hurricanes, and so on and so forth. But the other thing to look for is the increase in frequency and maximum wind speeds. So this is a nice work by Kerry Manuel and colleagues. So linear trend from 1980 to 2016 from the global best track data shows that the frequency of maximum wind speeds have increased with a large range, and you can see the percentage is not just 10, 20, it's hundreds. So the increase is now almost 400% over this period for certain range of maximum wind speeds. So the power dissipation index, or the accumulated cyclone energy, is going up because of the warming. Atmosphere holds more moisture, which fuels the cyclones. Ocean is warmer, which provides the energy and moisture to the cyclone. So this is not something that we can easily ignore or wait to see if the numbers are amounting to a trend or not. Okay, so extremes are definitely some big risks associated with climate change and global warming.